Have you heard about Blasthole drills? These powerful heavy machines drill deep holes in rock formations at mines and quarries, making it possible to blast away the overburden efficiently. Today, let's learn how to calculate total power requirement of a Blasthole drill. Whether the rig is electric or diesel-powered, its generated power is a critical parameter. From the air compressor to the hydraulic motors and cylinders, numerous heavy-duty components demand ample power to operate reliably. The engine power of a Blasthole drill typically ranges from 250 to over 1,500 horsepower, depending on the size of the machine, hole diameter, and application, whether it's used in mining, quarrying, or large-scale construction. In medium and large drill rigs, compressor is directly coupled to non-drive or flywheel end of engine. The compressor serves two critical jobs in Blasthole drills. One, it powers the air needed to flush rock cuttings from the hole as the drill bit advances. And two, in down-the-hole DTH drilling, it supplies high-pressure air to the hammer that actually breaks the rock at the bottom. On an average large Blasthole drill, the compressor can draw between 350 and 1,200 horsepower. That's around 50% to 60% of the total engine power, sometimes even more when drilling large diameter holes or at great depths. Next, let's go to drive end of engine. In medium and large drill rigs, engine's drive end is normally connected to a gearbox using a drive shaft with universal joints at both ends. The gear train inside gearbox multiplies engine speed and torque to multiple pumps. In some rigs, even compressor is also driven by gearbox instead of flywheel end. To achieve AF the total power requirement at drive end, we need to find out how much flow these pumps generate. Based on the flow rate and system pressure, the power requirement can be calculated easily. These hydraulic pumps supply hydraulic fluid from tank to all the motors and actuators or cylinders. This includes the track motors for tramming, jacks for leveling, mast lift cylinders, feed cylinders, rotary head motors, loader swing cylinders, joint braking cylinders, and more. Every subsystem demands its own unique combination of flow and pressure. To size your pumps correctly, you have to calculate the power for each circuit. Hydraulic power in kilowatt is equal to flow in liters per minute multiplied with pressure in bar, divided by 600. In imperial units, hydraulic power in horsepower is equal to flow in gallons per minute, multiplied with pressure in pounds per square inch, and dividing this by 1714. Don't forget the accessories and optional components. List every function, estimate its flow and pressure, and add those to your total hydraulic load. Tally and efficiency losses, plan for 10 to 15% overhead because nothing runs at 100%. Always size your engine above the peak combined load to handle tough mining conditions and future upgrades. Remember, prioritize the compressor and tram motors on tracks, add every hydraulic and electrical subsystem, account for losses, and skip anything powered externally. If you found this breakdown useful, hit like, subscribe, and check out my other videos on mining machinery systems.